Hi guys, we're going to be flipping out with Pythagorean theorem. This is our last STAAR review. You have the white worksheet, and we're going to go ahead and just review squaring a number, square rooting a number, and estimating square roots before we solve Pythagorean theorem problems. So this is just a review. Just to square a number, so for example, if I have 6 squared, we know that that means to take 6 and multiply it to itself. So 6 times 6 is equal to 36. I want you to go ahead and put a star by 14 squared because you're going to be responsible for that one. Next, I'm going to do the square root of a number. Square rooting a number means that I'm doing the opposite of squaring a number. So if I have the square root of 49, I want to know what number times itself will equal 49. And I know that to be 7 because 7 times 7 is equal to 49. Go ahead and put a star next to the square root of 144. You can go ahead and do that one. Let's go ahead and estimate the square root of a number. To estimate the square root of a number means that the number underneath the radical symbol is not a perfect square. So that means I have to estimate it. It's going to be between two whole numbers. Well, in order for me to figure out what two whole numbers it's between, I need to find out what two perfect squares the square root of 22 falls between. So, memorizing my perfect squares, I know that the square root of 22 falls between the square root of 16 and falls between the square root of 25. So I know that the square root of 22 is between 4 and 5. And go ahead and put a star next to the square root of 79. You can do that one on your own. Let's go ahead and fill in the blanks here. I have the Pythagorean theorem formula is, this is on your mathematics chart, so you don't need to memorize it. But it is a squared plus b squared is equal to c squared. And that means that in a right triangle only, it only works for right triangles, the sum, which means all the parts added together, of the areas of the two legs equals the area of the hypotenuse. Well, let's go ahead and just review what a hypotenuse is. The hypotenuse is a side across from the right angle. It is the longest side. It is the diagonal of a right triangle. And we call it C. There are two Pythagorean theorem triples I'd like for you to remember. The first one is 3, 4, 5. The next one is going to be 5, 12, and 13. And the reason we want you to memorize these is because you'll often see them on problems, but you'll more likely see a scale that they use 3, 4, and 5, or 5, 12, and 13. And I'll show you an example of that further down. Here we have the side lengths of a right triangle, so let's go ahead and label our right triangle. I'm going to find the square, the right angle, and across from that is the hypotenuse, so I'm going to label that C. The two legs are connected at the right angle, so I can label them A or B, it doesn't matter which order. This particular problem here, the areas of the squares of a right triangle, let's just go ahead and label the squares. So I'm going to find the right angle. Across from the right angle is C. So that means this square is C squared. And I have the two legs connected at the right angle. So I know that this side is A and this side is B. That means that this square is represented by A squared and this square is represented by B squared. Okay, so that's just a really quick review of Pythagorean theorem. Let's go ahead and solve some problems together. Number 1, a right triangle is shown below. The triangle is dilated by a scale factor of 2.5 to create a new triangle, and they want us to find what is the perimeter of the new triangle. Well, there are two things happening in this problem. First, I know that I'm going to be using the scale factor, and secondly, I need to find the perimeter of the new triangle. Well, I have a couple of choices here. I can choose to use the scale factor on the three sides and then find the perimeter, or I can find the perimeter and then use one scale factor. So that's what I'm going to do first. I'm going to go ahead and find the perimeter, and then I'm going to use the scale factor, which equals 2.5, to get my answer. Well, if I need to find the perimeter, I know that the triangle has three sides, and I don't know what this side is here. But since I know that this is a right triangle across from the right angle, I'm missing the hypotenuse, which is C. I'm going to go ahead and label 6A, and 8 is B. Now I'm going to use the Pythagorean theorem, and then I'm going to show you a shortcut. So first I'm going to write down my formula, which is a squared plus b squared equals c squared. And I know a is 6, and I'm going to square that, plus b, which is 8. Don't forget to write the exponent, which is 2. And then c squared. I'm going to go ahead and solve this now. 6 squared is 36, plus 8 squared, which is 64. And if I add the sums of the areas of the two legs, that'll give me the area of the hypotenuse squared. So 36 plus 64 is equal to 100. So that means that the square is 100 square units. Well, I don't need that. I need to find the hypotenuse. So I have one more step I have to do, which is to take the square root of 100. And the square root of 100 is equal to 10. So that means the length of the hypotenuse is 10. So I'm going to come back up to my picture, and I'm going to write 10 is the hypotenuse. So now I have all three sides. I can go ahead and find my perimeter. But one more thing before I do the perimeter is I wanted to show you a shortcut. The reason we wanted you to memorize the Pythagorean theorem triples of 3, 4, 5 is because if you see the relationship, if you see a pattern between your sides of the right triangle, then oftentimes you can use that same pattern without doing the formula. So let me explain what that is. So if I know that 6 is the smallest of the two sides, I'm going to put that under 3. And 8 is the next largest number, so I'm going to put that under 4. And I know I'm missing the hypotenuse, which is the longest side, so I don't know this number here. Well, is there a number, and this is only by multiplying, you cannot add or subtract, you have to multiply. Is there a number I can multiply to 3 to get 6? Well, I can multiply by 2. Can I use that same number and apply it to 4 to get 8? Well, 4 times 2 does equal 8. So that means I can use that same number for the hypotenuse side. So 5 times 2 equals 10, which is what we calculated our hypotenuse. So this is a shortcut using the Pythagorean theorem triples and scaling it up. And this is another way by using the actual Pythagorean theorem formula. Okay, so let's go ahead and solve the problem. I need to find the perimeter. So the side was 6 plus 8 plus 10. 6 plus 8 is 14. And 14 plus 10 is 24. So the perimeter of the old triangle is 24. So I'm going to come back up here and put a check next to perimeter. Next, I need to find the scale factor. So I need to apply that, not find the scale factor, but apply that scale factor to my old perimeter. Since this is the perimeter of the old triangle, I need to find the perimeter of the new triangle. Well, if you have remember things that we talked about for similar figures and dilations, we know that I can take the original perimeter, multiply it by the scale factor to equal the new perimeter. Since my scale factor is 2.5, I'm going to take 24 times 2.5. So I'm going to come up to the side here and do my calculations. I'm going to take 24 times 2.5. 4 times 5 is 20. 5 times 2 is 10, plus 2 is 12. 2 times 4 is 8, and then 2 times 2 is 4. I'm going to go ahead and add those two. That's 0. 8 plus 2 is 10. Carry the 1. 4 plus 1 is 5, plus 1 more is 6. Don't forget to move the decimal over. So I'm going to move it over once. So that means that my new perimeter is 60 centimeters. So the perimeter is equal to 60 centimeters. And that's how we solve a Pythagorean theorem problem that also involves scale factor. Okay, let's go ahead and move on to number 2. Alex is putting a fence around her garden to keep rabbits away from the vegetables. The diagram below shows the perimeter of the garden. Alex measured 3 sides of the garden, but her measuring tape was not long enough to measure the 4th side. What is the garden's perimeter? Well, so this is the fourth side here that she wasn't able to directly measure. So looking at this picture the way it is, I'm going to have to break this up into a simpler problem, which is one of my problem-solving strategies. I know that there are two shapes to create this figure here. And if I go ahead and draw a line down here, I've divided my shape into a rectangle and a triangle. More specifically, this is a right triangle. So I'm going to go ahead and label what I know. Since I know that the height here of this rectangle is 12, I'm going to label this 12 as well. I know that the length of this rectangle is 14, then I know from here, from this line to this line is 14. And so what I'm missing is this side here. Well, since you know that this creates a right triangle, you can use the Pythagorean theorem to solve it. So I'm going to first identify or find out where the right angle is, and here it is. I'm going to find the side across from it, and that is called our hypotenuse. I'm going to label that C. And I have a choice of labeling the X and 12 A or B. I'm going to label 12 A, and this is going to be B. So I'm going to use the Pythagorean theorem, which is A squared plus B squared equals C squared. And some of you right now are thinking to yourself, well, she had me memorize the Pythagorean theorem triples, and I know that they are 5, 12, and 13. Well, 13 is the longest side, so I know that that has to be the hypotenuse, which matches my picture there. And then 12 has to be one of the legs, and I know 12 here is one of the legs. So that means that the missing side here has to be 5. But I'm going to go ahead and prove it with the Pythagorean theorem. So A squared is 12. I'm going to square that. B squared, the length of B is unknown, so I'm going to just write B squared. And the length of C is 13. I'm going to square that. 12 squared is 144. Plus B squared is equal to 13 squared, which is 169. Since I have to solve for B squared, I have to get rid of this 144. So I'm going to subtract it from both sides of the equal sign. So these two cancel out. I'm left with B squared is equal to 9 minus 4 is 5, and 6 minus 4 is 2. So that means B squared is equal to 25. Well, I don't need B squared, I need B. So what I'm going to do is, well, that last step, which is to take the square root of 25. And the square root of 25 is 5, which is what the length that we said using our triple was supposed to be. So now I have all my sides labeled, and I'm now able to calculate the perimeter. So I'm going to go ahead and add up 13 plus 14, which is 27, plus 12, which is 39, plus 14, which is 53, plus 5, which is 58. So the perimeter of this figure of the garden is 58 feet. Let's go ahead and turn on the back. I would like for you to do number 3 on your own, so go ahead and put a star by that. We're going to go ahead and do 4 together. A can of Dr. Pepper is in the shape of a cylinder with a height of 12 centimeters and a radius of 4.5. What is the length of the longest straw that will fit inside the can? So let's go ahead and label what we know. We know the height is 12 centimeters. So on my can here, I know this is the height, so I'm going to label that 12. The radius is 4.5. Well, I know that the radius is from the center of the circle, so that's going to be 4.5. And they want us to calculate the straw, which is this dashed line right here. And we don't know how long that is. But if you kind of highlight your figure here, you can see that if I highlight the straw, the height, and across the bottom, it creates a right triangle. So that means I'm going to need to use the Pythagorean theorem to find the length of the straw. Since the right angle is here, and the side across from it is C, that means I have to calculate for C. So I'm going to set up my Pythagorean theorem formula, which is a squared plus b squared equals c squared. And since I've labeled the hypotenuse C, I have these two sides, these two legs, so I'm going to go ahead and label this side A and this side B. A is 12, so I'm going to write 12 squared plus, well, some of you might want to go ahead and write down 4.5, but since this is the radius, I need to find the full length across. So I'm going to double 4.5 times 2, or 4.5 times 2. 5 times 2 is 10. 2 times 4 is 8, plus 1 is 9. Move my decimal over once. So that means this entire bottom length here, or the length of that leg, is 9. So I'm going to write 9 squared there, and I'm looking for c squared. 12 squared is 144, plus 9 squared is 81, is equal to c squared. I'm going to go ahead and have to add 144 and 81. 4 plus 1 is 5. 4 plus 8 is 12. Carry the 1, and then 1 plus 1 is 2. So 225 is equal to c squared. But I don't need the area of that square. I need the side length. So there's one last step, which is to take the square root of 225. And if I memorize my perfect squares, I know that the square root of 225 is 15. So the longest straw that could fit inside there is 15 centimeters. Let's go ahead and look at number 5. I want you to go ahead and circle that one and put a star by it. And number 6 is the one we're going to do together. On number 6, we know that we can do Pythagorean theorem on a graph. So here they want us to find the length of the line segment called AB. Well, all you see here is a line. Well, if we start using our highlighter, we know that we can create a right triangle with that line AB. And if I do that, then I have a right triangle. And I'm going to go ahead and start labeling my sides. So there's my right angle. Across from the right angle is the hypotenuse, so I'm going to label that C. These two are the legs, and it doesn't matter which one's which. I'm going to label that A, and this side B. So I'm going to go ahead and write down my Pythagorean theorem formula, which is what I should write down every single time I have a right triangle, and I need to use the formula. I need to know how long the sides are. Well, since it's on a graph, I can use the square sides to find the length. So I'm going to measure from the right angle to point B, which is A. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that means the length of A is 8, and the length of B is 1, 2, 3, 4, 5. So underneath A squared, I'm going to write 8 squared plus underneath b squared, I'm going to write 5 squared is equal to c squared. 8 squared is 64 plus 5 squared, which is 25. And if I add the two together, 4 plus 5 is 9, and 6 plus 2 is 8. So 89 is equal to c squared. But I don't need the square of that, or the area of that square. I need the side length, or the hypotenuse. So the last step is to take the square root of 89 to get c. Well, some of you may be wondering, how do I find the square root of 89? Well, 89 is not a perfect square, so here I'm going to have to estimate. I know that the 89 is between two perfect squares, and it is greater than the square root of 81, but it's less than the square root of 100. And I'm now going to see which one it's closer to. And so 89 is closer to 81. So I know that the length of C is approximately 9 units. All right, I hope you guys learned a thing or two about Pythagorean theorem, and you guys have a great night. Bye.